Assalamualaikum and very good day. So my name is Nur Alif bin Nur Afandi from group number 2, and my group members is Nur Aisha and Naima. So this is a video about the assignment given by our respected lecturer. Okay. So you can see this is our ladder diagram. So for our ladder diagram, the holding circuit is we use internal memory. So you can see this. This is our internal memory. And then by looking at the question, the question demands us to have S1, which can detect the presence of ice cream cone, and also a fault sensor to check the condition of cone, where it says that the sensor will produce high if the cone is broken. The machine doesn't add the ice cream and other items if the cone is broken. So we're gonna take a look at these two things first. So this is the broken cone, which we propose using move function as our broken cone, and this is our fault sensor, and this is our S1, which detects the presence of cone. So we're going to run simulation to our ladder diagram. So firstly, I'm going to show you how does the fault sensor and S1 work. So pressing the start button, okay, you can see S1 is on, which means there it detects the presence of cone. So the conveyor belt, based on the question, the conveyor belt running from S1, and then it goes to ice cream, goes to add chocolate, and then lastly it will add sprinkles. Same goes to our ladder diagram. Same to the question, which is first the cone will add ice cream, and then add chocolate, and then add sprinkles to the cone. And then you can see we use the timer function. We name it as gap. The gap here, the gap in the timer represent the distance between the ice cream machine, chocolate, and the sprinkle machine. And at the same time to create a loop. And then this is how the fault sensor works. And then we assume this move, the hashtag 1 here, represent 1 in hexa, is presented as broken cone, which means that the broken cone we made it manually. So if we turn on the move button, it will then transfer the 1 hexa into this compare function. Firstly, before we turn this on, the compare function compare 0 and 0, which is equal. That's why this S1 will turn on. But if we set on to this move function, the fault sensor will turn on because 0 is less than 1. We used P less than to create equation, to create condition, so that the fault sensor will turn on. And then the question also demands us to create an emergency button, which is used to stop the overall system, but the count remain at the current value. So let us take a look at our current value of count. So this is our count. So the current value for count is 77, if I'm not mistaken. Oh no, we have to stop. We will show you how our emergency button works. Okay. Excuse me. Okay. Beginning from the start. Okay, let's take a look at our count here. So the count is 99. And then 98. So this is our emergency button. If we turn on, the system will stop, but the count remain the current count number, which is 98. So our emergency button is successful. If we turn off, the process will continue. And then the question also demands us to make the count reset after 100 cone filled by sprinkles. So we need to wait 100 cone. So how does we turn on the green light, yellow light, and red light is by using the shift register function. By using 200 as our address. So starting from the beginning, let us show you. Let me show you, okay? Okay, the question says, if below 60 cones have filled by sprinkles, green indicator will on. And if more than 60 cone have filled by sprinkle, yellow indicator will on. And then if 100 cone have filled by sprinkle, red indicator will on, and the conveyor stop. So let's see. Let us see. Will it happen according to the requirement? Okay, so the machine is started. So below 60, yes, green light will turn on, which means that already one cone is passed. So the yellow light should turn on when the counter goes to around accurately 39, if I'm not mistaken. 100 minus 39 is equal to 61 cone. And then the yellow light will turn on. So we have to wait. We just have to wait until the count go to 39. Okay, now our cone is reaching almost to 39. So we just have to wait. The count go 39, and then the yellow light will turn on, indicating 61 cone had been filled with sprinkle. So now we just have to wait. Now it's getting closer to 39. And then the yellow light turn on. See? Indicating above 60 cone, which is 61. 61st cone already crossed, already have been filled with sprinkles. And then we just have to wait until red light to turn on when the count reaches 0. And now, as you can see, we are reaching to the 100th cone have been filled. So now it's 10 cone left, as you can see. So once the counter reaches 0, red light will turn on, indicating that 100 cone had been filled with sprinkle, which is exactly the same requirement as the assignment question demand us to do. See? The red light turned on, indicating 100 cone had been filled, and then the counter also reset to 100 once the red light turned on. So this is the address used, which is 200, 203.12, 206.03. Bear in mind that shift register only shift the bits within, only shift 15 bits in one address. So there's require a little bit of calculation in order to get the exact amount of the exact number of address should be used to get a 61 cone and 100 cone. So this is, as you can see, this is the address that we use. That's all from us. Thank you very much.